All right. Good morning. My name is Brook Stevens. I'm with Seakeeper. Hopefully, everybody's sort of familiar with Seakeeper, or at least heard of it, or if not, I'll explain a little bit about what we do and what Seakeeper is all about. Just to start here, should be a video. In a nutshell, this is what we're able to do on various hulls. I mean, this is just one example of a center console, but what we do is we attach a gyroscope to the hull of the boat, and basically it eliminates the boat roll or reduces it drastically. You know, we strive to achieve 70 to over 90% of the boat roll. And we've got a new product that we just introduced. We'll be shipping it next month, I believe, or May actually. It's the Seakeeper 2. It's our smallest system to date. It's our lightest system to date. DC powered like our 3, so you don't need a generator to run it. You could basically bond a foundation onto deck level in many instances on center consoles, under leaning posts and things like that. So we're continuing to get smaller and smaller, getting into more and more boats out there. And obviously it's more aggressively priced than any other system that we've manufactured in the past as well. Just a brief rundown. Again, I think a lot of you guys may have been here in the past when I discussed the company, but we're the world leader in vessel stabilization. We are based in Southern Maryland and California, Maryland. We manufacture near Reading, Pennsylvania. Our facility up there continues to grow and grow, and we're about to outgrow it. We're to the point where we can produce about 6,000 systems a year. We also have offices in Fort Lauderdale as well as Italy, and other representatives elsewhere around the world also. Yeah, the regional sales and service hubs, again, Florida, technicians and sales team down there, Singapore as well, Italy, UK, and also in the Middle East, what isn't shown on here. We're over 160 employees globally, and we've shipped more than 6,000 systems since March of 2008 when we began moving product all around the world. We've shipped to every continent. Here you can sort of see what we've done thus far in terms of gyro ship per year and what we're targeting and where we think it's going to go as we get smaller and more compact, and it opens up a lot more opportunity for us. We shipped about 1,500 units last year, and we're targeting over 2,500 this year. And you know, by 2021, we're expecting to be up around the 10,000 units a year mark. This presentation was more, I decided to do the one that's more focused on the commercial military side, but obviously our business is huge on the recreational side as well. These are just some of the larger commercial brands we've worked with in the past. On the recreational side, I mean, it's more difficult for me to name builders that we haven't worked with than it is, you know, that we have. We've probably worked with over 500 different builders on the recreational side. The next slide is just basically talking a little bit about boat roll principles, and it's basically a sample graph of a Seakeeper stabilized vessel. We target vessels that have a natural or resonant roll period, which is typically in the range of like 2 to 5 seconds or so. And when the wave encounter period is close to or matches this natural roll period, the boats typically roll 3 to 5 times the slope of the incident wave. So basically, you know, as you know, it gets in resonance and the rolling amplifies. And what our product does is essentially throws torque down through its gimbals as it precesses to reduce that amplification. Stabilization these days is, it's becoming more of a demand every day. This was a article in Trade Only magazine a few years back, but some of the top innovations in the marine industry over the past 25 years. And, we were right up there with the joysticks and pod drives and GPS even. So, it's been a big breakthrough, and we feel like we've been changing the game here. Obviously, some of the benefits, you've got the safety factor, your increased productivity on commercial boats, more days on the water, increased profitability, improved crew performance and retention. A lot of the same thing goes for the recreational side. It just enhances your overall experience on the water. Obviously, if people are susceptible to seasickness, it makes a drastic difference for them as well. And it's something that enhances the experience for everyone on the boat, not just the captain. You look back at your GPS or your joysticks and things like that. Usually the captain only benefits from those, but Seakeeper benefits everyone on board. Obviously there were the traditional fins that have been around for forever. The gyro, it's all internal, so there's no added drag, minimal power consumption. Again, our two smallest systems are DC powers, so they'll run, a pair of outboards will typically run them. For instance, we have a couple of demo boats that we've run. A 32 contender with twin 300 Yamahas will run our Seakeeper 3 just if the engines are on without any batteries at all. If you turn off the engines, 2 house batteries will run the system for 3-4 hours maybe, depending on the sea state you're in. So they don't consume much power at all. The larger systems are AC powered, so you would need to run a generator, but it's usually only a couple kilowatts, all in. The installation's flexible. It doesn't have to be on center line. It doesn't have to be, midship or anything. Weight distribution is really the only thing you need to consider. Our one restriction is we don't want to be too far forward on a planing haul, just because we don't want to get a lot of vertical acceleration, pounding on the bearings and things like that. Other than that, though, if you can structurally tie into the boat properly, the system will perform regardless of where it's located. Again, today we're starting to break into more and more center consoles where we're actually putting them on deck level under leaning posts and things like that. Obviously, the penalties of the fins, potential damage, grounding and drag penalty and that sort of thing. This was just a quote from Power Motor Yacht magazine. Really, feeling is believing. To feel it work is the way to go. So if you're ever able to get on a demo boat, we highly encourage it. It's pretty wild to feel the difference. Here locally, we'll have a demo boat at the Bay Bridge show. I think that's coming up next month. If anybody's around and wants to check it out, come see us. And we've got demo boats all around. We've got one running around the West Coast right now, one at the Palm Beach Boat Show currently. So that's really what we've been trying to do here as of late, is just get as many people as we can out on the boat to actually experience it. So our demo fleet has grown significantly here as of late. The concept of gyro stabilization for vessels has been around since the early 1900s. Otto Schlick and Elmer Sperry developed it way back then. Weight, power consumption, just these gyros were massive. And, what we've been able to do is just bring everything down in size, power consumption, using the latest and greatest in technology, which I'll go into here in a little bit. There's an image of some gyros installed in This is back in 1932 on board a 814-foot ocean liner. There were 3 of them. Each flywheel had a diameter of 13 feet and weighed 108 tons. Our smallest one now weighs 414 pounds, I think, and it'll stabilize a vessel up to 7 tons. So probably about that big compared to these big ones. So how we do what we do, it's like the flywheel rotates at a high rate of speed here on a vertical axis, and what we do is we spin it inside of a vacuum. So in doing that, we can spin it much faster with no air friction using a lot less power. The more benefits of the vacuum is, it's contained from the salt environment and that sort of thing. So everything inside, the bearings, the flywheel, the motor, is all protected. And what happens in spinning as fast as we can in that direction, the boat actually, if you picture either the bow or the stern that way, you can rotate them 180 degrees. But what happens is the gyro actually tilts fore and aft, which is kind of counterintuitive. You think it may tilt port to starboard, but it tilts fore and aft, and it basically pushes and pulls on its gimbals, like I stated before, and throws right angle torque down into your stringers or your foundation, which basically grabs the boat and holds it, and you basically just sort of go up and down over the waves like this instead of going side to side and having all that uncomfortable roll. And we control the rate in which it tilts back and forth. We don't drive it. It wants to do that on its own, just due to the principles of the gyroscope. But we control the rate it tilts back and forth to maximize the performance throughout the whole roll period of the boat. Again, this is sort of getting down into more of what I was just discussing. Our flywheel spins, over 500 miles an hour on most of the units. It generates enough force to stop the boat from rolling. And the tolerances we work in, it's the flywheel is it's like a fraction of the width of a hair, to where it's in its enclosure. I mean, the company that we partnered with early on, which we acquired not too long ago, they just did some of the most precise work that we could find, and we've been with them ever since and growing every day. Again, the vacuum, the benefits, it surprisingly cuts down the power consumption drastically. You would think just cutting out the air friction would help a little bit, but it would take like 3 to 5 times, I believe, the power consumption if we spun that flywheel at the same speed in open air. So we're able to spin smaller flywheels faster and again, get everything down in size and try to make it more practical for more vessels. We do have a liquid cooling system. We bring raw water into a heat exchanger, just in and out, and we have a closed glycol water loop. We got a little glycol pump that circulates a glycol water mix through the cooling caps. Basically, it cools the bearings, the electronics, just the entire system. So you can kind of tuck them away into some pretty tight spaces and things like that, and not have to worry about a lot of ventilation. They run very cool, surprisingly, considering that thing's spinning and they're that fast. I mean, it could be running all day on a hot day, and you can put your hand on it, and it's warm. They don't get very hot at all. When it comes down to maintenance too, on the larger systems, that's your most routine item is a little pencil zinc on that heat exchanger. The smaller systems, we don't even have a zinc on the smaller heat exchangers these days. Again, the active control or how we control the system, in its tilting or precessing is with these hydraulic rams here, we basically open and close solenoids and transfer fluid from one arm to another to control the rate at which it tilts back and forth to maximize its performance. So if it's a really rough sea state versus a really light sea state, the seakeeper is going to want to precess or tilt accordingly to wipe out the roll, and we're just going to control that to help protect itself and help maximize the performance again. In terms of sizing and performance, like I said before, we strive to achieve 70 to 90+% roll reduction on every project that we work on. So we look at each boat and we take a peek at the displacement. That's really the key more so than the length. The vessel displacement is key. The waterline beams and lengths are key, and then the GM, or the transverse metacentric height, which is essentially this measurement here, the distance between the metacenter and the vertical center of gravity, which a lot of the, well, naval architects that we work with have or can get that or can estimate that. A lot of the builders have no clue what we're talking about, but we can estimate it as well if we have those other three specs or parameters there. So we take a look at those specs, and then what we can do is provide a performance prediction showing various configurations of seakeepers. You know, you can use multiple small ones, let's say, or one big one to get that level of performance that we strive to achieve. And then obviously real estate is a key with a lot of the builders too, or retrofits where there may just not be space for one big one. So sometimes we have to tuck multiple small ones away and things like that. And then we also have a pretty extensive database of sea trials where we've, on the 6,000 plus systems we've shipped, we've actually collected data on versus off in various sea states on a lot of these boats, and have those reports as well. So if customers come and say, hey, I have a 70-foot Viking, you know, we have actual sea trial data that we've collected on those boats that we can provide. Now we can even offer that to end customers if they want to sort of see what their seakeeper is achieving or any of that. They can do it. We've got an app, and I imagine pretty soon we'll be able to get to the point where they can probably spool their seakeeper up using their phone. I know that's coming. We recently got to the point where we can control the seakeepers through the large, Raymarine, Garmin, Simrad screens and that sort of thing. So which basically mimics our small display that we have that comes with the seakeeper. In terms of spool up, when we initially turn it on, it does take a little bit of time to get it up to full RPM. Once it gets to about 70% of the rated RPM, you can begin to use it or unlock it and allow it to tilt back and forth, which is going to give you the righting force. That's usually about a half hour or so on the smaller systems, a little bit longer on the larger ones, and then it'll continue to climb to its rated RPM for another, depending on the system, 15 minutes, 20 minutes. But for the most part, I tell owners and captains, and if you know you're going to use the boat that day, have it be one of the first things you turn on when you're going through the boat and get things ready. Typically, by the time you get out to any exposed seas, you'll be good to go then. This is an example of the performance prediction I spoke of. You've got your hull parameters up there that we looked for, and this is basically showing the unit that we recommend and the basically percentage of roll we feel that we're going to be able to dampen in various degrees of uncontrolled boat roll. So in this case, if the boat's rolling 10 degrees or 15 degrees in resonance, we still think we're going to be able to knock out over 80% of that with this model, probably more, especially if it's a lower sea state down in here. then we feel like if the boat's rolling at about 20 degrees, which can be pretty drastic, we still feel like we're going to be eliminating 68 or so % of that with that single system. And again, if there weren't room for one of those on that boat, you could look at like 2 16s, you know, that would be equivalent, you know, to like a 32, you know, so there's multiple ways to skin the cat a lot of times when it comes to figuring out what the best way to go about it is. This is an example of the sea trial report that I spoke of. When we run those, we usually go out again with an app and just basically put the little iPod down on the dash or whatever and collect data for about 10 minutes with the Seakeeper off, where the boat's going to just be rolling as it would without anything going on. And then we engage the Seakeeper and take 10 minutes on and basically overlay those two data points there, and it gives you your percentage. We try to collect underway data as well. You know, the Seakeeper will work, you know, in any sea condition and at any boat speed. You don't ever have to turn it off or calibrate it or let it know that it's sitting still or going, you know, it just constantly reacts to the environment that it's in. So in this particular haul, we got 90% roll reduction, and it's hard to read there, but it looks like it was like 1.8 meter seas at 9 seconds, you know, not terribly rough, but looked like 9 to 12 knot winds on that particular day. If it were a nastier day, it would have probably got less performance out of it. Yep.
One of the things with boats I'm finding is that you're using buoy data instead of real-time data, and we're finding some discrepancies in some of the actual sea trials and the performance. We're working with the manufacturer over this. It's like the buoy data will say it's 2.5 based on the real time and what is particular forecast, but a real time you might not have a foot and a half. And we did this the other day on the boat, and we proved it because we had a 60% roll reduction, and then we went back the next day, very similar conditions, and we went up to an 80% roll reduction. It was, I mean, it was just a difference in how the buoy data was interpreted in their computer program. I mean, you got the little iPad or the software where the app was being checked, and but that was a big concern of my customer. And we got it worked out, but it was all based on wave height.
Okay. Yeah, I mean, every day is going to be a little different. I mean, when we do our sea trial reports, you know, just the best way we figured out that we could sort of showcase what the weather was that day was just take a screenshot of the buoy weather website. But yeah, the Seakeeper, I mean, it's got its own built-in algorithms in the software and that sort of thing. So it's just going to react to that same day, and in 2 hours it dies down a little bit, and you know, and the frequency changes and the waves or the wave height changes. It's going to just react accordingly. It doesn't take any of that into consideration, but just to try to show, like, you know, we're not saying we achieve 90% on a 30 knot, you know, small craft advisory day or something like that. We just try to do our best to be as transparent as we can on these. This presentation was more focused on the commercial military side of things, but so we obviously have our recreational line of products. We also have what we call our HD systems, and these are the systems that we market toward the commercial military and your more hardcore sport fishing guys that are going to be out in heavier seas and putting more hours on than your average recreational customer. And all the HD line is we're spinning the flywheel slower, so it's just software. So our 7 HD is our Seakeeper 9 on the recreational side, same animal physically. We're just spinning the flywheel slower, and in spinning the flywheel slower, we're going to be throwing less loads into our bearings, and the unit's going to last significantly longer. So we offer twice the warranty on the HD line as we do on the recreational line. And again, we're going to see extended bearing life due to spinning the flywheel slower. So the 12 HD is our Seakeeper 16 on the recreational line. The 20 HD is our 26 on the recreational line. The 30 HD is our Seakeeper 35 on the recreational line.
So by turning it slower, is that mean the boat is slower or still running at the same speeds?
The boat?
Like, so we're cruising 32 knots in the boat.
The flywheel spinning slower in our product. That's the boat.
So where we're at. So what's the difference? You turn it slower, you turn it higher. When we're trolling inside to a quarter and C, we get slack pretty hard. And then the 7, by turning it slower, we're still going to have 80% roll.
You'll get less. You'll get less performance.
We'll have less roll reduction.
Less roll reduction, but extended bearing life. So that's your sacrifice there. If you decided to go with a product that may give you more bearing life, spinning it slower will provide less roll reduction. But you know, if you're building a new boat or something like that, you could also plan for that and maybe go up a size, but then spin it slower and sort of have the best of both worlds too. But
so what happened with the Seakeeper 5 and 6?
Going away from the 5.
Yeah.
That was more just creating more of a separation in the product line, because we had the 3, and then we had a 5, and then we had the 9. So we just decided to make the 5 a little bit more efficient and turn it into a 6. More honestly, probably more for marketing purposes than anything else, and just creating more of a 3, 6, 9, 16 step up in terms of our products.
What is the bearing life on one of these? I know you can't, they have different models, but what that seems to be the Achilles heel, then the heat exchanger, I would think, right?
The bearings really, I mean, that's a heat exchanger is a minor fix compared to a bearing failure. You know, we actually have to swap out, you know, the whole sphere, the ball has to come out. We can't service the bearings in the field, unfortunately. And it's truly been all over the place, you know, and again, the more hardcore conditions or the harder you work on, you know, the less bearing life you're going to have. And we have systems out there with 20,000 hours on them that are on yachts, but those yachts may not be going offshore and, you know, heavy seas that often, you know. So it's really about those loads that we're throwing into the bearings when that thing's precessing hard and it's rough, you know. So spinning slower certainly helps that, and we're seeing exponential bearing life by spinning them slower. And we've also taken a lot of steps in-house over the past 10 years that we've been doing this to help. And we've learned so much over the years about just how moisture affects it. I mean, condensation inside this, I mean, you name it. And we've recently been dabbling with a different bearing manufacturer as well. So it depends on the boat and the use, but it's hard to say. I mean, on average, I would say 5,000-7,000 hours. I mean, and again, we've got a bunch of boats out there with 10, 15, 20,000. Then again, some fail at 2,000. You know, it's tough to really say.
What happens if the heat exchanger system is out? That's a cooling system, right?
Mm-hmm.
Basically. So what do the temperatures go? I would think that's another potential problem. If that goes out and fails, is there a shutdown or something in the system, like an overheat, like it would be on a generator?
Mm-hmm.
Okay, that's
the first component in our scope to heat up. Let's just say your strainer gets clogged and we're not getting adequate flow to the heat exchanger. It's really the motor drive box, the electronics. They heat up quicker than anything else, and once they reach that threshold to where they're hot, it stops the unit and spools it down. So
Well, to ask this question, you may not be able to answer it, but this long-term testing on structural analysis, failure analysis on boats, materials analysis, are you guys working with any naval architects to look at the long-term effects that these gyros are putting on some of these high-speed hulls? Not so much the displacement hulls, because that's not, because you're talking about massive accelerated stops and rates of returns. Has anybody addressed that, or do you guys look at that now that you got a lot of units out in the field?
I mean, I think have done more of the homework up front, you know, than we have internal applications engineers. And I'll use the center console market as an example. As we've sort of broken into that, we've gone around to probably 100 center console builders and looked at how, because we're literally bonding these things down to their decks, looking at how their decks are tied into their grids or lack thereof. I mean, you know, we just had a 37 Edgewater customer the other day that wanted to do it, and we went to Edgewater and really learned how their deck attached to their grillage there, and they didn't feel like it was adequate for the loads that the Seakeeper was going to throw into that deck. So we just didn't do the project. In terms of looking at boats that we've installed these on 10 years ago that are still running strong and stuff like that, I don't think we have done a lot of testing on that. I mean, but
now, do you have an internal, on that same thing, do you have an internal group that will go out on a retrofit of an older boat, like you're seeing a bunch of these, not a bunch, but a bunch of old Trumpies that have been retrofitted? Do you have guys that go out and will assist the installation? Yeah.
I mean, our applications engineers will get involved. Ultimately, I mean, we're like an engine company that just distributes the product. We don't really get involved into the installation itself, and we, you know, recommend naval architects, you know, get involved, especially on maybe an old wooden boat like that. But we've done quite a few now, old wood Trumpies and things like that. And, you know, when we started, we had our M7000. It was a little bit larger than the 7 HD or the 9 now. And then we stepped up to a 21, which was around this size. And the very first 21 we put on a boat was on an old Trumpy. This was probably back, I don't know, 7 years ago. And it's been running strong ever since. I mean, in terms of any structural issues that the boat has experienced, I know of none, honestly. There's been poor installations where back in the day we bonded them down solely. We basically had almost like U saddle beams that ran the length of the unit, and we just used adhesive, and you build up your stringers and you bond them down. And there was poor installations where they just didn't install them properly, where the unit pulled off the stringer, not the stringer itself, but the unit kind of came up off of the stringer. Again, it didn't tear the boat up or anything, but it caused problems. But I don't believe in-house that we've done a lot of tests on boats that have been running for years and years and years, and look, because we really haven't had any complaints. I mean, you know, it's certainly torquing on the hull and the stringers like engines and things, and the waves pushing on the stringers and everything, or the structure of the boat from the outside as well. But I mean, we're not breaking boats up.
Question then for a surveyor: if a surveyor encounters one of these in a boat, presumably, obviously, they report that it's got the unit in it.
Right.
Would you expect the surveyor to test it in any way, shape, or form, or are you only going to do a switch test on it, or what can a surveyor do?
I guess they could contact us in our service department and report back the hours, and we could maybe give them an idea of what maybe should be looked at in terms of make sure that, you know, the zinc is good, or the heat exchanger has been taken care of. The foundation looks good. You know, the bolts are fastened properly. There's no bolts backing out or anything crazy like that. But other than that, I think just sort of a visual check of the foundation, make sure nothing looks out of whack. But our service department would be happy to be involved in any sort of situation like that. And depending on the hours, look at the service interval, or, you know, that sort of thing. In terms of the maintenance overall, like I said, it's the most frequent thing is taking care of that zinc on the heat exchanger. And then really after about 1,000 hours or so, you know, you could check the seals on the hydraulic rams. You can maybe flush that cooling. that sort of thing. But the truth of the matter is the overall life of the unit comes down to the bearing life, and you can't even get to the bearings anyway, so there's not a whole lot to do. There's no oil changes or anything like that. Most of the key components are within that sphere, which we don't really disassemble once installed.
What would be the symptom
Of a bearing failure?
Loud noise.
Noise. Yeah,
Loud noise.
that's always the tip
Besides
off.
the spitting would be like a squeal.
Yeah, I'm sure the power consumption is probably higher as well, but the noise is the first thing. All of a sudden, my Seakeeper's making a crazy noise, and truthfully, you can still run the thing, but it's loud and no one wants to. And what we say is, okay, just send us a quick video on your phone, and our engineers can tell pretty much right away.
Is there a chance of it coming apart or anything like that within that case?
Mm-mm. No, if guys are using the boats and they need the Seakeeper, tell them just keep running it. It's not going to do any additional damage, but the bearing is shot. We need to swap out the sphere.
And what's that cost? Depending on $1,000, $2,000.
No, it's more. It's a higher percentage of the overall cost of the unit. I mean, that whole sphere unfortunately has to be replaced, and that's the bulk of the system. Honestly, I mean, really the frame and the brake system and everything else. But I don't know the exact percentage, but what we do is, and we have trade-in programs, and we have remanufactured spheres and remanufactured units that we offer as well. So there's ways to do it
Well, less expensive.
less expensive than just pulling the whole thing out and putting a brand new unit in. But it would vary by system. I mean, our Seakeeper 2 that we're going to be shipping here in a month or two, it's going to retail for about $22,000. So I don't know what a sphere replacement would be on something like that. Maybe 8. I don't know. I'd have to talk to service, but it's not cheap. It's a bulk of the system, but that's what would need to occur if you do have a bearing failure, is the sphere needs to be swapped out. Jumping back into this, these are just some of the statistics of the systems that we published and make available. The speed we spin the flywheel. We don't title the units on the RPM it spins. Ironically, the 7 HD spins 7,000, but as you can see, the 12 HD only spins 4,600. The unit names the 7, the 12. It's really the Newton meters of angular momentum that we provide. And so on the 7, it's 7,000 Newton meters. On the 12, it's 12,000 Newton meters. You've got your torque there, which is, it's really more about the angular momentum than anything. That's your horsepower. That's really what is getting it done, and the most important stat there is. There again is your spool up time, and then your spool up time to stabilization. So the 7, in about 25 minutes, you can engage it. In another 10 minutes, it'll be up to full speed.
How long does it take to spool down? About the same.
Hours. It's in that vacuum. It's I mean 4 hours, 6 hours. Depending on the unit, I guess. With that being said, I mean you when you go to turn it off, it basically locks in place and just spools down. I mean, the center consoles and that sort of thing that are going on lifts and trailers, I mean, you don't have to wait till they spool down or anything, because when it's locked in place, it's not exerting any forces or anything like that. Like I said, all of our demo boats are trailerable now, so we just.
But all that in downtime would still be wearing out the batteries. I mean, the bearing.
It's really about the loads going into the bearings when it's tilting and exerting its forces. When it's just spinning, it's really not. It really does come down to the precession and the loads that are being thrown in heavier seas than anything else in our experience. So what we do in terms of our warranties and our life, we actually have 2-hour meters, and one is motor spinning, and then one is actually working. So we go off of when it's working. there's your power, AC and DC. It's 3 kilowatts to spool up both of these systems, for instance, and it'll operate at about 1 to 2 kW. It'll never exceed 3 on these systems. The weights obviously vary. You know, the keys to what we do, the weight of the flywheel, how fast we spin it, and then getting that weight sort of outward on the flywheel to create more momentum. But for instance, the 7HD, that whole system weighs about 1,200 pounds. You'll typically handle a vessel up to like 30 tons, I believe. The 12 will probably handle a 50-ton boat that weighs about 2,100 pounds. The system's weight, usually it's about 1.5 to 2% of the overall displacement of the boat, usually. Just in terms of the dimensions, the 7HD's about 33 by 35 wide, about 28 high. So on a bigger boat, I mean, you can typically find real estate. Sometimes, again, you have to maybe find space off center line or whatever, but where there's a will, there's a way in a lot of cases. In terms of the noise, it's usually about 68 to 70 decibels, sometimes a little over 70. That's where we tend to ship them from the factory, if that's where they are, at 1 meter away. You know, and a lot of times in engine rooms and that sort of thing, or if you're nearby a generator, you're not going to hear the Seakeeper over that. And you can put a sound shield over them if you need to, like the ones we're putting under leaning posts and that sort of thing. Sometimes we'll insulate them a little bit just to keep them a little bit more quiet.
On the bigger units that have the cooling pumps, are they thermally protected if the cooling pump fails or the unit shut down?
Oh yeah. Mm-hmm. Yep. And if all cooling went out on the boat, you know, if you lost all power on the boat and you lost your raw water pump, the glycol pump on this Seakeeper stop, if they spool down with no cooling at all, we've found that it's not going to damage anything.
Please, Brook, stop me where my math is wrong. But if I take your Newton meter measured at 1 meter length and divide it by the equivalent in foot pounds, 7.37, divided by 17.5 inches from the center line that steers to the outside, loading, I come up with 650 foot pounds loading on each stringer every time it moves. Is that right?
We do have those loads calculated on each model. I don't know if that is the way that it exerts those forces or not, but I can show you on our drawings. We have every angle and the loads it's putting on every force, twisting loads, everything. So each model we have that calculated.
That's 627.52. What I come up with per mounting
Per mounting
The thing
point.
is, they're not constant.
not constant.
That's the key to it. It's not a constant load at maximum angle.
Right.
It varies.
Yeah, but we have all of that on the drawing on each of our installation drawings that we provide the builders and the guys doing the refits and that sort of thing, so they can build accordingly.
And so, forgive me, if the DC input is 24 volt DC, how do you do that on outboards?
The smaller units are actually 12 volt. Yeah. And all the DC powers on the larger systems, it's just running the display and the glycol pump. That's it. Again, your bigger systems here, and all of this is published on our website and that sort of thing. The recreational line, like I said, it's, you know, we're spinning the flywheels a little faster than the HDs, so this would essentially be the 7 HD. That would be the 12. But this is the recreational lineup. Again, it's just software that's different on those HD systems.
So when you say hot, is that 150 degrees, 220 degrees? What is the rest? How much can you kind of get rid of?
trying to think of what our temperature thresholds are internally. I mean, physically touching them, I mean, they just can get warm. I mean, that's running all day in a hot environment, in a hot engine room and that sort of thing. So it's, I mean, we have, trying to think of where our alarm thresholds are set. But I can't remember off the top of my head, but I can get that for you if you want.
But it's not enough to overheat a receiver space.
No, nowhere close.
So one more question on like installation of the, like you say your small, it's your smallest recreational. What can you expect to pay for an installation on that? I mean, this is obviously kind of do it yourself. A lot of yards have no clue.
It's, you know, a lot of times I'll equate it to installing like a generator. You know, your foundation is key, and then it's electricity and raw water. I mean, that's really it. You can take existing stringers and glass them up to where your mounting points are correct, or, you know, glass in a aluminum plate to drill and tap and just bolt straight down. You could fabricate a foundation that would go over existing stringers for the unit to bolt to. So it varies from refit to refit. And that's something else. We have a very extensive database of just pictures of all these crazy retrofits that have been done, and you know, installs at the factory level that builders have chosen to go with.
I'm thinking about it at the factory level, much cheaper.
Yeah, I mean, everything's opened up, and you can design your stringers out of the gate to be the right width, and you can, you know, laminate in your plates and things to bolt to and that sort of thing right out of the gate. But retrofits can be more challenging, of course, but it's still about 30% of our business is refits. We've introduced a new touch screen recently. It's a little larger than our old one, but it's nice, and you can, again, run through your Ray Marines, your Simrads, your Garmin's, the 8000 series Garmin, I believe. And so you can basically hide the Seakeeper display completely and not have to clutter up your dash. I know these days guys just have your big.
Does the new one have the oscilloscope in it when it's working and not working, or is it just something that I made?
No, it does. I think that you can go into that screen as well. Yeah. And we can retrofit older models with the new screens and that sort of thing. But I think everything since last October that's been shipping has got the new touchscreen. I think that what has got us here, for the most part, aside from the product being just tremendous in terms of performance, is the service. You know, we really did spend a lot of money and go above and beyond right out of the gate to try to service these things, because they're expensive and guys get spoiled. You know, they get to used to this thing, and if it stops working, they want it back online quick. I can't use my boat. My Seakeeper's working. I was like, what? You boated for 50 years prior to having a Seakeeper. You can't use your boat today? But no, we gotta be quick to get there and get them right, because you know, it becomes a real key to what guys do, and you know, with their families, or if they're with their wife or their kids or anything, you know, they want to have their Seakeeper working. So we've got a pretty extensive service network, and aside from our own in-house technicians that we have sort of spread out around the world, we work with third-party yards and you know, technicians, and you know, some big massive yards that can haul huge boats, and then we work with guys that are mobile and run out of the back of their pickup trucks. And so really, whoever can help us provide the service we need, and whoever can provide, you know, great service in terms of retrofits, in terms of pricing and reliability and quality work. You know, we work with all different kinds of businesses around the world to try to help keep our systems up and running as much as possible and get more systems out there. Again, this was more of a commercial military presentation, but I'll just run through some of the commercial military vessels we've stabilized over the years. This was a range support craft. We did quite a few of these, not only built by Magitech, but Marine Group Boat Works in San Diego. And these torpedo recovery vessels, I guess, is what they really do. They go out and do a bunch of trainings and things like that. On this particular haul, they chose to go with 3 of the 26s, basically 1 on the center line and 2 off center line. This was a smaller one of those similar style vessels. They went with a single 26 on it. It was an 85 footer. They retrofitted this one, I believe. This was out in Seattle. This was actually built to be a drone boat, and I don't think they ever really built a whole lot of them, but the Seakeeper was standard in it because they were going to use it to, the Seakeeper to basically as a weapons platform, but also all your satellite feeds and everything else to controlling the boat remotely. They felt stabilization was key. They were using what would now be the 7 HD or the Seakeeper 9 in terms of the recreation side. Some Hong Kong police boats. I think they were 62 footers. They were using one single Seakeeper 26. Again, if it were today, they could have opted for the 20 HD. So a couple of some crew transfer vessels. Boats run guys out to like wind farms and things like that to work on them. I think this one they run guys out to oil rigs to do service and that sort of thing. Again, I think these are more wind farm supply vessels. Yeah, these are we haven't broken into any of the American pilot boats yet for whatever reason. Been close, but keep going to vote. I don't know why we haven't gotten in there, but I think we will. These are some from UK and then Germany and the Netherlands there. And I think that's it. But yeah, I can answer any further questions, or I can show you some of those loads. I can bring up my computer and show you some of those foot-pounds and where they go and that sort of thing. It's no problem. I could actually bring it up online. Is this online?
Can be, yeah.
You can get to our website. I can bring up some of those drawings.